theoretical part is called Android development, and I will go through most important topics what you should know about Android operating system and what you need to know to get started, and some of my highlights in programming approaches for Android applications. And first question may arise why Android needs to be discussed in this class. It is depending on how you look on computers. If you count mobile devices like phones and tablets as computers, then Android is the most popular operating system in the world. If you do not count mobile devices like phones and tablets as computers, and you think that real computer should have at least keyboard, dedicated keyboard, then it is the most popular operating system for these mobile devices. And second most popular operating system for mobile devices is iOS, developed by Apple. And then everything else is just dusty corners you don't need to care about. And what is important here is that here again we see this unequal distribution where Pareto principle applies very perfectly, that 80% of system is taken by one, most popular one, then 80% of remaining 20% are taken by some other operating system, and then 80% of remaining 20% is taken by some other operating system. And what is also very important is that when you look on market capitalization, which in general means total turnover of money in this particular market, then this Pareto distribution is absolute opposite. For example, if you develop application for both iOS and Android or something similar, probability will be very high that your income will be higher for iOS system and like 80% and 20% for Android system. Why? Because Apple in general is marketing company like Adidas and Nike, because real phones and programs are developed by somebody else somewhere in Taiwan or China, but they do marketing and they do it very well. And therefore consumers of iOS are much more ready to spend money and big money on applications, gadgets than Androids, and therefore usually iOS is used for management level of companies, Android for everybody else. And because managers are always more equal than everybody else, usually they require that your application will work for iOS, that means for them, and for everybody else, that means for all other employees in their company. And what is important about Android is that it is open source operating system for mobile devices. In theory, you can put it in some other systems as well. In practice, I have not had much of successful cases. And first release was in year 2008. Current release is version 10 point something. And until versions from 1st to 9, they also added so-called code name for them, and code name was from some movie, I don't remember which one, but it's about these different kinds of sweet candies. But starting from version 10, it is called just Android 10 without specific code name. And to make their development costs lower, Google decided that this part, which is responsible to make life into hardware, will be provided by Linux kernel. And Android operating system uses the same Linux kernel we are using on PC compatible computers or ARM compatible computers like very old and very new Apple computers, etc. And then on top of that, they took and cherry-picked some other open source projects as a native libraries for performance reasons and because they are ready. The most important one is FreeType fonts, SSL libraries for encryption, SQLite as a built-in relational database to store data, OpenGL as a hardware acceleration for graphical tasks, for graphical libraries, and some other things. And then one of these native libraries is a virtual machine for this particular platform. And in most cases, this platform is ARM compatible processor with all related chipsets and hardware around it. And this virtual machine is Java compatible virtual machine. So Google decided that design of Java is not bad, and so decided to use Java as its programming language and system. But for technical and legal reasons, first, because at that time Java was not well supported for ARM architecture for these mobile devices, and for legal reasons they actually took design of Java, but they re-implemented entire Java infrastructure by themselves from scratch. So, and then it runs this Android virtual machine, and then there are different kind of application frameworks for graphical interface, for networking, etc. And then you have these Java applications. But these Java applications actually are collections of Java applets. So when I told you that I will not discuss in details applet technology inside web browser because it's pretty dead, so no need to discuss it, then what you actually call Android application from theoretical perspective should be called Java applet, not application, because application has public static void main method and it starts from its main method and it takes its own virtual machine. But applets use the same virtual machine and they work like servlets, and servlets work like applets, so they are loaded into the same shared virtual machine and they respond on specific events when something happens in your virtual machine, and then specific code for these applet methods are executed. And in older Android systems, this virtual machine was called Dalvik, but for newer virtual machines it's called ART as a three-letter abbreviation from Android runtime. And particularly for this Android runtime, it is much more funny virtual machines than old school Java virtual machines, because actually many of these parts of these applications are not running inside Java virtual machine, but they are recompiled and are executed as a native libraries, like these built-in libraries which comes together with Android operating system. What is also quite interesting is that there is almost no much of support for GNU utilities what we have inside Android system. So Android in general is poor Linux kernel, some of these mentioned libraries, no GNU utilities, and then Java applications. And when Google decided to re-implement design of Java by themselves, because this is actually different implementation of Java, not OpenJDK or some other closed source packages developed on top of OpenJDK, there are differences. For example, up till to most recent versions of Android, only these Java language features are supported and implemented which are described in Java 8. So everything else which came after Java 8, like 9, 10, 11, 12, 13, 14, 15, these Java language features are not supported and probably will not be supported because more than a year ago, Google decided, I think it's not even more than 2 years ago, Google decided that default programming language for Android operating system will not be Java, but Kotlin programming language. So-called apps, which are Java applets, consists of 4 important different parts. Most important part is activity. An activity is one single screen what is visible to user. Every time you create another screen for your applet, you actually create another applet. So activity is one single applet in the collection of your application. So you create new activity, and lifeline of this activity is like for any Java applet. Then you may have different kind of services or service which are run in background in separate part. For example, when you create clock or timer or whatever, then you create different kind of services. Then there are content providers, which are like service providers, which are already built in Android operating system, which allows you to get events from your mobile phone. What is happening with this phone, like data from accelerometer, data from GPS, data about incoming calls, incoming SMS messages, etc. And then you can create so-called broadcast receivers. You can create these applets which receive these messages and handle them. So here this approach is again event driven, and you subscribe to these events, and if you have subscribed to an event like incoming SMS, then this incoming SMS event is also sent to your application, and then you can handle it somehow whatever you do with this particular event. Now about compilation and runtime. If you develop your application in Java programming language, you have .java file. If it's Kotlin, then .kt file, and then you compile it. If it is Java compiler like Java-C, you compile it to class file. If it's Kotlin, you use Kotlin compiler, and again it compiles it to the same format of class file. And this bytecode also is absolutely compatible with Java class file for personal computers. But then black magic happens, because running something inside virtual machine is more safe but also more slower, and most reason for slowness is garbage collection, memory management plus garbage collection, because if you have garbage collection and memory management, it will always be slower because of these management overheads. So then it does another translation, it recompiles, and formally it's called translation, because compiler takes text and provides binary code, but translator takes binary file and produces another binary file. It creates so-called ART executable.dex file, which is more platform dependent, and then starting with Android runtime, virtual machine, not with Dalvik machine, it is then executed as a native code inside this physical computer, not inside virtual machine, but like another native application into this system. For older virtual machines it was still like in standard Java virtual machine, but actually starting with like Java 11, OpenJDK also works in similar fashion. It may recompile some parts of your classes into native binaries and execute them as a native binaries in your physical computer. So, then when you create your application, one important configuration file is Android manifest.xml, and it is similar as manifest file for your jar file as an executable Java application, archive for normal Java applications, and it says what is a minimum API required, what hardware features should be enabled, what external libraries are needed for this application to run, and also what kind of permissions this application needs to run. And it says what are activities inside it, what are services inside it, etc. In most of cases you configure this file automatically while you are adding new files in your project and saying, for example, start from this activity or whatever. And here is example. I will not go in details, but I will describe in more details this life cycle of activity or this applet. So for Java standard applet there was approximately 5 different methods: init, delete, refresh, something else. But for Android this applet life cycle is a little bit more complicated. When you see some activity running, it is in running state. And when you launch this activity, it goes through events on create, on start, and on resume. And if you don't need all of them, you of course can call, for example, on start and on resume all from on create. Then you run it, and then these other states of this applet are important. What do you do with this activity? If you have more than one activity inside your particular application and you switch to it, then all these activities are running in their own separate thread. Then this particular activation of this applet goes on to, it executes on pause method, and then it goes to the sleep. So it's not executed. So it's put somewhere in swap file or swapped into memory for later execution. Then other thing may happen, and then when you go back to this activity, it goes through on resume method. So on resume method is called, and then you go activity running again. Then you may switch to completely different application, like you go to home screen, you open different application, and then this particular activity goes through on stop method and goes to sleep. And then when user navigates back to this particular application, and then it sleeps again, doing nothing, then it goes through on start and maybe on restart if you want to start it from new, but usually you call something on start. And then user may go to home button and choose this button something like close all. Then entire activity is destroyed, and before that on destroy method is called, and this activity is shut down. And this is exceptional case, for example, if Android runs out of virtual memory, and virtual memory means collection of random access memory in chipset with swap file in persistent storage. So if it runs out of this virtual memory, there's not enough, then this application may be killed because it's in background, so not so important, and it is going to on create. But in general, normal workflow is what I described to you. And all these run in separate thread, and you do not manage when exactly these methods will be called, because it is managed by this Android application framework itself. But because it's separate thread, it's also monitored by other threads for running for monitoring purposes inside Android virtual machine. And they can monitor this process, and you may see different kind of warnings. For example, if it doesn't respond for a long time because it tries to read something from network and the network is slow, etc. So Android recommendations is following that every time you run some slow operation, you do asynchronous calls is callback. So here is thread of your particular activity. And if you need to do something like read from network, what Android Google recommends for you is to do asynchronous call. We separate the thread, and then when it is done, you do callback from this thread that it is done. Otherwise, if you do it synchronously, like here is your activity, and you do it from network, and so synchronous call would be colored. So you wait, and then when it's done, you finish and continue. Somewhere here, some other monitoring thread may say it is slow. Because here are some other threads which monitors your activities, how do they behave. We will do this practically in practical exercise. So now a little bit about user interface. For Android Studio it is not so user friendly, at least beginners friendly, than like Window Builder for Java GUI applications. But it also uses model view controller approach, and static part of this view can be designed in Graphical Designer, and you create a XML file with structure which says how you create element inside element in this graphical wizard. And important part for these elements is their identifier. And then when you refer to these graphical elements from your source code in controller part, then you do something like JavaScript approach. At least for me it looks like JavaScript approach. You have static object called R from resources, capital R, and then you can say something like refer to it by ID, and text view, for example, to refer to this somewhere then, and then you create variable which refers to this statically designed graphical element to handle it. And similarly you can also do find by, you call method find by ID for a source with identifier, this particular one, and then you initialize this variable, and then you do something like about this. So not so easy as right click and add event handler as in Window Builder. So that other considerations you need to remember. First, these are not Java applications, these are applets. What does it mean? There is external lifeline of main thread inside Android itself, and that is its external life starts when you start this virtual machine and ends when you end. And your application is made in asynchronous call in separate thread for your particular application, let's say application which is, if it's has screen, it's activity. And then inside this activity, your start, stop, destroy, blah 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 methods are called externally from this main thread when these particular events happen, when user opens this activity, closes, etc. So all this management comes from outside. And then of course this may be left in virtual memory, and some different activity may be actually active. And then it goes through the stop, destroy methods, etc. etc. And when you go back to it, it is not like you are switching in your task manager following. Here I should see. For example, here, these all background applications, what I have here in this switcher with Alt Tab, these are actually still running. All the data structures are intact. But because these are proper, fully fledged applications, but for applets, it is differently. For applet, when I go back to particular activity, nothing is remembered here. And if I switch in one mode, for example from other application to this, again, only thing what will happen, on start will be called, or whatever these were called, to be precise. Yeah, on create, on start, so there is no prehistory before that, and there is no history after these methods are called. And that means that you cannot do something like this, what you do in normal applications, that even though you are switching to different application in normal computer, this application actually is still running. And if you created some structure and you created some elements, and then you, with your task switcher, you go back, you actually continue it from the same place with all prepared data structures. But for applets, Lifeline always starts from new. And if you did store something and then go back, only so much of code will be executed as there is code in this onStart or onCreate method. And this means that actually you do not have persistent memory here inside these applets. What can you do to create persistent memory? For example, this onStop method, you have to store it in persistent storage. And typical example is this file system provider. You write it like in named file, like I do not know, status of his name, and then something like your status variable. And then when you go back from onCreate or onStart method, first thing you do, you read from this. So you write it here, and you read it from file system again to restore your memory. So remember, here is no memory more than you have memory inside particular method. And all these methods are always re-executed from scratch without any prehistory. And of course, if you need some more structured data and you do not like to write this like a serialized objects in your files, then you can use relational database like this SQLite database as your service provider or something other. So that is very important, and what you do in these methods, you can always check. For example, if it's not null, you continue. If it's null, you recreate it, or you always just read them from your external persistent storage like file system to read these values back. So that's one thing. Then logging is much easier in Android applications than in standard Java. In standard Java you have to create your own logging object and do this, but for Android it's already provided to you. It's called log with capital A because it represents static structure. Then when you do develop something, you should start with all possible permissions and then you restrict them. So that's if you develop them for yourself. But if you download something from Google Play, then of course you download some utility and it asks permissions for your contacts, for your SMS messages, for your phone conversations, etc. Then probability is very high that it's some kind of malware which actually tries to steal your data and send them to big browser. And so that's one thing you need to consider. Another thing is always remember that each particular activity runs in its separate thread. And for example, when you need to start something which takes some time, you are always recommended to create new separate thread for this particular activity. How do you synchronize your data between these activities? Until you see that it's too slow, my recommendation is very simple. Read it into file system, write it back, write it into file system and read it from file system. Because first it implicitly creates serialization. You will not have, not serial, but serial access. So it implicitly synchronous. You will never have different kind of racing errors when competing threads try to access something in some unpredictable random way. And second, it is persistent storage. You will always be able to remember things what you need to remember. Only when this doesn't work because it's too slow or whatever, then you should do something more complicated. And so if you will need, we will discuss this in more details later, but probably that is the most important thing you should know about theory so far. So, do you have any questions or comments on that?